Hello, myself Pranita. I am from CSE AI and ML. My topic is differentiability of a function. Before entering the topic, let's understand what is a function. What is a function? Function in mathematics, an expression, rule, or law that defines a relationship between one variable, the independent variable, and the another variable, which is the dependent variable. The relationship is commonly symbolized as y equal to f of x. In addition to f of x, other abbreviated symbols such as g of x and p of x are often used to represent the functions of the independent variable x, especially when the nature of the function is unknown or unspecified. For example, for the area of circle, a equal to pi r square gives the dependent variable a the area as a function of the independent variable r the radius. Now let's understand what is the differentiability of a function. There are some types of definitions of differentiability. This is one of the example of differentiability. Let's take an example f of x as x cubed minus 3x plus 2. To check whether it is differentiable or not, we should do the limit x tends to 0 f of x plus h minus f of x by h. If the limit h tends to 0 f of x plus h minus f of h by h for the function f of x is exists, then the function f of x is differentiable at x equal to h. Now let's see another definition of differentiability. At a point C on the interval a comma b of the function f of x, where the function is continuous on ab, if both the limit extends to c minus d by dx of f of x and limit extends to c plus d by dx of f of x exists but are not equal, then the function f of x is not differentiable at the point C. That means when limit extends to c minus d by dx of f of x is not equal to limit extends to c plus d by dx of f of x, then the function f of x is not differentiable at the point C in the interval ab where the function is defined. Let's see some rules on differentiability. Sum and difference rules. When f of x is equal to g of x plus h of x, then the differentiability of f of x is equal to derivative of g of x plus derivative of h of x. That is, f of x equal to g of x plus h of x, then derivative of f of x is f dash of x equal to derivative of g of x, that is g dash of x, and derivative of h of x, that is h dash of x. That means f dash of x equal to g dash of x plus h dash of x. This is same as a difference also. When f of x is equal to g of x minus h of x, then f dash of x, that is derivative of f of x, will become g dash of x minus h dash of x. For example, take f of x is equal to x plus sin x, then f dash of x will be derivative of x, that is 1, plus derivative of sin x, that is cos x. Therefore, derivative of f of x will be 1 plus cos x. Let's see another theorem in differentiability. Product and quotient rules. Suppose f and g are defined on interval and are differentiable at x naught belongs to that interval, then the function phi of x equal to f of x into g of x is differentiable at x naught, and the derivative of phi of x will be derivative of f of x into g of x plus derivative of g of x into f of x. Same like that, if when g of x is not equal to 0, then the function mu of x equal to f of x by g of x is differentiable at x, and mu dash of x will be g of x into derivative of f of x minus f of x into derivative of g of x by square of g of x. That means we can prove that phi of x naught plus h minus phi x naught is the limit extends to 0, phi of x naught plus h minus phi of x naught by h is exists. So the function phi of x is differentiable. Same like that, the function mu of x is also differentiable. Let's see another rule, composition rule. Suppose f is defined an open interval I and x naught belongs to I, and g is defined an open interval containing y naught such that f of x naught let phi equal to g naught into f. Then we have, suppose f is differentiable at x naught and j is differentiable at y naught, then phi is differentiable at x naught and phi dash of x naught equal to g dash of y naught into phi dash of x naught. Suppose phi is differentiable at x naught, g is differentiable at y naught, and g dash of y naught is not equal to 0, then f is differentiable at x naught and f dash of x naught is equals to phi dash of x naught by g dash of y naught. Suppose phi is differentiable at x naught and f is differentiable at x naught and f dash of x naught is not equal to 0, then g is differentiable at y naught and g dash of y naught is given by phi dash of x naught by f dash of x naught. Let's see some examples of differentiability. Here we have d by dx of x is equals to 1, d by dx of sin x is equals to cos x, d by dx of cos x is equals to minus sin x, d by dx of tan x is equal to secant square x, d by dx of secant x equal to secant x into tan x, d by dx of cosecant x is equals to minus cosecant x into cot x, and d by dx of cot x is equal to minus cosecant square x. Here, all these functions are differentiable, hence we can find the derivatives of these differentiable functions. Hope you understand the differentiability concept. Thank you.